Okay, good day. I'm hoping this is streaming. Maybe? Okay, I think we are streaming. So, with that said, I'm going to go back to YouTube. It sure looks like we're streaming. Yeah. Okay, so let's see if I can get my windows in the right spot so I can make sense of what I'm doing. Otherwise, things get weird. No, stop that. Don't you love Windows? It thinks it knows what you're doing, and well, it doesn't. Okay, so welcome to the Tuesday live stream. I hope everyone is doing well. I'm just going to start out with an apology to my eyesight class. The foundations of physical science. I can never remember what the class is called. Yeah. So I'm trying to transition how I'm teaching that class. I'm trying to do more active demos, more things that y'all can use in your classrooms later on, because that class is focused towards students who are teaching majors. And yeah, that did not work today. I am sorry. That lecture was lousy. I am going to do my best to do a better job next week or Thursday. Anyway, so for starters, my apologies, eyesight folks. I will do my best to do better for a lecture that's not so next time. And I will remember to bring enough things with me, because one of the tricks if you're going to do demonstrations, you need to bring stuff. And I brought the rubber ball, and I didn't bring the medicine ball or the dumbbells, which would have been helpful. I probably need a skateboard for that one, but I don't have a skateboard, and I'm kind of afraid of breaking something. Me being the something. So we'll see about that. Hopefully the rolly chair, if I recall, it's a terrible rolly chair. Okay, so that embarrassing part's over. Let's move on to the next one. Okay, so in the to-do list, or in kind of the discussion list from discussions, the eyesight folks, not too much in the discussion forum. I'm not surprised, though, since y'all just had a test. But a couple questions in the survey of chemistry class. And these, I'm quite certain, are from folks who are in the Thursday class because they're about the lab. So if you're in the Tuesday class, I'm sorry, you've already done the lab, so this isn't going to help you. So you already know what it is. So we're doing. Wow, I'm getting too loud. Okay, OSB is telling me to quiet up. Let's see. Yep, there we go. Okay, so the lab this week is a chemical reactions lab, and normally we would be doing this in like early October, because of course COVID-19. And so one of the things we're doing that it's like, I don't like this, but I understand why we're doing this, and I don't have a better alternative, is that a lot of the labs are taking place much sooner than they would otherwise take place. And this way, if someone gets quarantined, they're out for a couple of weeks and they come make it up, or if we have to cancel, classes go full online or something, well, we got the labs out of the way. That's what we can't move online, at least not easily. We got Labster coming online, which could allow us to do online virtual labs, which I am totally not looking forward to. So hopefully we don't need to do that. I do not want to do those. But they're supposed to be good. The demos were like, yeah. Anyways, so normally we would have covered chemical reactions, and this would have been after we talked about chemical reactions when y'all would be doing this. But you're doing this in advance. That said, I think it's fairly straightforward what you're looking at. The analysis is going to take some work, but that's why it's not due for a while. Once again, sometime in October, if I recall. I don't have the schedule. Yes, I do. No. That's an old schedule. Anyways, so with this one, it's really two labs that are separate that are combined together into one lab. So the first lab, you're checking chemical reactions, and what you're looking at is different types of chemical reactions. So when we do actually talk about chemical reactions, we'll talk about gas-forming reactions and precipitation reactions and redox reactions, single displacement, double displacements, that kind of stuff. And in Lab 8, you're going to actually get to do some of these. So most of them are going to be redox reactions. You'll see a gas-forming reaction or 3. You'll see a precipitation reaction, which is also a double displacement in this particular case. And you'll see a redox reaction that's a single displacement. So there's half a dozen tests there. Point of confusion that has been kind of big on this one, and it's one of those is like, I'm pretty sure I know how English works. I know I've got the sentence set up right, but I don't know how to get it not bulky, but also like clear. So it's one of those is like English itself. I'm blaming English. I'm blaming the language, which is my default. It's not I'm bad at spelling. It's English doesn't know how to spell. It's the language. But it's one of those is you're reacting hydrochloric acid with a list of chemicals. Elements. I mean, elements are chemicals. Magnesium, aluminum, and zinc. And it's hydrochloric acid with aluminum. New test tube, hydrochloric acid with magnesium. New test tube, hydrochloric acid with zinc. And this is one of those is where, if I was better at English, I could make this a little bit more clear, but I don't want to write out, 3 different sentences because it gets really bulky. So it's this kind of this ebb and flow or give and take between clarity and conciseness, which, eventually I will probably figure out and or retire first. Probably the latter, truth be told. Okay, so yes, that's going to be part of the experiment. So you're going to do those reactions. Now, one of the other reactions that's in there is the double displacement one. And so in that case, you're reacting sodium carbonate with copper, whatever the copper solution is. It's copper nitrate or copper chloride. It's one of the two. It's probably copper chloride. I don't remember which one it is off the top of my head. I'd have to look at the lab book itself. And that one's hopefully going to form a precipitate. So what you don't want to do is have a powder already in there. It works fine. The chemistry does fine, but you don't really see what's going on because you get this reaction where the liquid that the copper is dissolved into dissolves the sodium carbonate, which then immediately forms a precipitate with the carbon. So you see it, but you don't see it. It's harder to see. So in that one, you're forming aqueous sodium carbonate. And literally, it's just sodium carbonate powder, a squirt of distilled water. In this lab, you're doing nothing but distilled water. There's no, tap water in this lab. Tap water typically is for cleaning, and it is for water baths of type. So if you need to boil something and use an indirect heat, you would use tap water in the water bath that you're heating something up. So kind of like a double boiler. We use that a lot. But otherwise, no, we're using distilled water. If the water touches the chemical, you go distilled water. And so in that case, you make a, milliliter or so of aqueous sodium carbonate by sodium carbonate into test tube and then water into test tube. The trick on doing that, and I wish I had a test tube with me, but this is at home. My office ain't this big. This is my living room / office, home office / dining room / how houses go. But imagine this random flash drive was a test tube. The way you mix test tubes is you hold them up fairly high. And obviously, they're going to be longer. Let's get an ink pen. Okay, pencil. So imagine the pencil's a test tube. You hold them kind of by the top, and wherever you hold them, they won't splash any further. And then you're going to strum them. So you hit them kind of like a guitar. And it's easier on a test tube than a pencil. And this kind of flicks them, and you pinch up fairly tight. You don't want to break the test tube because, it's glass, and, that would hurt. But you want to pinch it so it's snug up here because any splatter will stop up here. You're creating a node. So you're creating the waves down here, and you create a node up here, and it won't slosh there. You can actually, if you take biochemistry or some of the biology ones, they end up mixing test tubes enough and other small tube things that they have vortices where it has like a rubber pad down here that shakes the bottom. And wherever you pinch, it will slosh it up to that level. Really cool technique. We're not doing enough of that stuff to justify vortices. If you're doing a lot of it, it really makes sense. It's a really good thing to buy. But, 2 or 3 test tubes, just thump, 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 thump the test tube, and you're good. Anyways, where was I going with this? So you make your aqueous solution, so you just dissolve that, then you squirt it in your copper solution, and hopefully, boom, you get this beautiful kind of bluish green precipitate in the solution. It's great. The other kind of tips, and I'm going to go over a lot of the core tips, in class again. If you've got some of our metals are a bit corroded, especially our zinc strips, they're just vintage. They've been around for a while. and you want to get the corrosion off of them. Ideally, you would scrape a lot of the metals because really all the chemistry is taking place on the surface, and any kind of surface coatings are going to interfere with the chemistry there. So it's great to scrape a lot of things. The one you really need to scrape is the zinc strips. And yeah, that's kind of the high points there. So Lab 8 is actually really fairly straightforward. The Tuesday class got done like half hour early. It's a really straightforward lab. I like it. You know, you get to see some cool stuff. You get to see some bubbles forming. You get to see some copper plating, some zinc. That's always kind of nice. And then the other part, you're making a battery, or I should say you're making an electrochemical cell. We're using the LabQuest, and we're checking voltage. And noisy car. And with that, then, you know, we're able to, you know, see, you know, kind of how the cell is working. Now, stuff that you're not going to immediately want to do. So record all of your observations. For the LabQuest, you really want to set up yourself a table, you know, red electrode, black electrode, and then write in the voltages, because you want to know, and once again, I'll mention this again on Thursday, you want to know which thing was hooked into which electrode and what the voltage was. Was it positive or negative? The value does not matter that much. You're not going to use that much. Now, for working up the data, what you're going to want to do for this lab, you know, I'm going to ask for like some balanced chemical reactions, a couple of things like that. Obviously, that just sits until we actually cover this. Once again, normally we would not do this lab until October-ish, once we have started well into Module 6. Which is near the end of Unit 2. So, you know, we're almost a whole unit ahead here. So at that point, then we'll learn about balanced chemical reactions, and you can do those. And it shouldn't be too hard. That's kind of with the first part. And it'll also be able to identify, oh, this is a precipitation reaction that had a powder. Oh, this is a single displacement. The zinc was covered in copper, that kind of stuff. And then the second part with the battery, that's actually a really cool one. It's a little bit challenging. It makes you think on this one. But you know by the sign of the voltage which way the electrons are going. Because you've got a chemical reaction, it's a redox reaction, so electrons are going out of one thing and into the other. So you know which way the electrons are going. You know the players, so you're actually going to figure out what the chemistry is taking place. So you know which players react. And really, you only look at the top voltages. Because you get a little bit of noise. The graphite is flaky, to say the least. I have not sorted out the graphite yet. I don't know if I need a different brand or what. But you'll only really look at the top voltages, and then that will start giving you clues as to how to do, or what the chemistry is doing. And from that, you can actually work out exactly what your chemistry is, which is a little bit of a challenge, but it's also one of those things where you've accomplished something once it's done. And that's also stuff, you know, just wait till we've covered Unit 6. Once you start on Unit 6, that'll be a great time to start working on it. There's no need to jump the gun on this one. I'm not going to collect this at all for a while. And I do apologize. I'm dreadfully slow on grading. You know, it's one of those, like, getting a whole bunch of stuff done. I've got some random paperwork that's in the queue kind of before some of the grading. So my apologies on that. Test coming up. Actually, test will be due shortly before the next live stream. So in that case, with that one coming up for my survey folks, eyesight folks, you just took a test. Survey folks, it's going to be a two-parter. One part's going to be on sapling, and it's going to have a very sapling feel. The second part's going to be on D2L, or first part's going to be D2L. The other part, you know how it goes, D2L, and that's probably going to be a little bit more of an essay feel to it. So I might be asking you to explain things like, you know, what are the 4 types of errors that we talked about, or something like that. So, and the goal here is, if you watch the last live stream, and I talked about Bloom's taxonomy, the sapling should be kind of hitting middle of the road, lower middle of the pyramid. And then the D12, I'm going to try and hit higher up on the pyramid, where you're kind of synthesizing and evaluating. I don't know if I'll succeed, but what I want to do is not just have it so you're parroting. You know, you're not being, you know, Polly wants a cracker. You're actually, you know, taking the information, compiling it into something new. Because, of course, it's an online test. It's open book, therefore, you know, random facts you can just pull off the book, not that helpful. But, you know, so I'm looking for something to show that, you know, you're thinking through this. And you could show me that, you know, you're awesome, you deserve the A. Let's see, that's about it for the Q&A. And so just a reminder, if you're in one of my classes currently, chuck a question in the appropriate discussion forum. For this one, what I do is about 6:15, I go through and look at my discussion forums for this week, and I pull the questions, so please feel free to chuck that in there. If you're streaming this and you're not one of my current students, feel free to check a comment on the bottom of the YouTube videos. I totally look at those also around that same time period, see if there's any questions to answer from there. So, more than welcome to chuck one in there. And otherwise, yeah, I hope you have a wonderful, I hope you've had a wonderful first half of the week. Hope your second half of the week is excellent. And I'm not seeing any comments in the actual comment section for YouTube, so I'm going to assume that we're good with those. And as such, have a wonderful day. And also, in the future, if you want comments, got questions for the live stream, feel free to chuck those in there. Okay, now that I've said goodbye as many times as the Lord of the Rings, have a wonderful day, and I will see you in later videos.